Hey everybody, I wanted to throw together a quick video on powering up in Revit because I know we've made some changes and we've got automatic wire sizing now and revised some of the panel schedules. So threw this together, gonna run through it real quick, try and explain everything. If anyone has any questions, feel free to reach out. Um, I know we've kind of talked about it a little bit in some of the Be the Best meetings, but I wanted to have just one video dedicated to the full process of laying out equipment, putting devices in, powering everything up, getting your panel schedules, how they should look, talking a little bit more about the automatic circuit sizing for your wires. So yeah, that'll be what this is. I'll just kind of jump in now. Threw together this quick single line diagram with some equipment on an overall plan. So what we've got right now is just an MSB main switchboard, 480 three phase, 4000 amps. We're going to power a 480 panel. That's going to be called HP1. Out of that, we'll power a transformer and then a 208 panel LP1. So the first step in all this, when you place your equipment down, obviously we need to give it a name. So I'll come to the MSB, find panel name, and we'll just leave this as MSB. And then my hotkey is TG for tag, and I'll turn the leader off. And we'll just kind of put it like that. If you want, you can leave the leader on, kind of point at the equipment, but that's MSB. Next, we'll do HPN or HP1. Do a leader again. So there's that one. This is going to be X former T1. And then last was panel LP1. Okay, so now we got our four pieces of equipment here that are coming back to the single line, right? The next part is we want to give a voltage to all four of these, and then we'll be able to power them up and create panel schedules. So on the switchboard family, it comes in at 480, and you can basically just select the distribution system. We're going to be doing a 480Y, not Delta, so I'll select that one. But for the panel boards like HP1 and LP1, those come in with just one pole and 0 volts. So we'll want to change that to 3 480 on HP1. And now we can change the distribution system, the 277 480Y. And then LP1, we'll do the same thing, except it's going to be 208 volts. We'll make that 120 208Y. Now the transformer is a little different because you've got a primary and a secondary voltage. So if you scroll down to the bottom, there's the distribution system. We'll put that on 480 delta because that should be the primary side. So we're not going to have a neutral from the 480 side. Um, the secondary is going to be 208Y. So let's see. Here it is, secondary distribution system, 120 208Y. Then we'll apply. Okay. So now our four pieces of equipment all have power. They got names, so we'll start making our panel schedules. Starting with MSB, we'll go to create panel schedules, choose a template, and I usually just use this one, switchboard with summary. There's our switchboard. This stuff you can fill in yourself. This is going to be 4000 amps. We'll just say 65 KIC. Okay. Now for HP1, we will do choose a template and panel board this time because it's not a switchboard. We're going to do with wires because we want to show our wire sizes for our circuits, and then with summary as well so you can see the summary of all the loads that are on the panel. And in my single line, I think I just made this a 200 amp board, so we'll just keep that as 200 for consistency. Transformer is not going to have a panel schedule. Come down to LP1, and again choose with wires with summary. And this one, I believe, is 250. Yeah. Okay. Now we've got panel schedules for our switchboard and our two panels. We can go ahead and power stuff up. In a normal project, you might power this off like a utility transformer. I'm not showing that for now, so if you saw, I just hit let me redo. So you select the equipment and you just hit power. And because there's nothing else upstream yet, we're going to leave it as none. We can go ahead and change the rating to 4,000 amps. 4,000 amps. That's just so it's something that's now powered in the elements of our system browser. And if you have like a utility transformer, you can send it back up to that. Next, we'll come to HP1. We'll do power, give it 3-pole, 480, and we'll send it to MSB. So before I do anything else, before I click anything else, after I power that up, you can see there's electrical circuit properties over here, like load name, HP1, connection type can be breaker or feed through. We're going to leave it breaker. We're going to leave the load name as the panel. We'll change the rating to be 200 to match our one-line diagram. And then this is kind of now one of the parts that I want to talk about on the wire type. We'll click over here. We come up to manage MEP settings, electrical settings, and wire type. So these are all the wires that we've created in our template for now. We got THWN 60-degree rated cable, copper, and then 75-degree rated copper. No neutral in case like you're doing a 480 delta. Then there's no neutral, right? So we want to have those options, which is basically just turning off the neutral here. We've got copper underground, which is going to be in non-magnetic conduit instead of steel. And we've also got the aluminum counterparts of those for copper. So based on what kind of material you're using in your project, you got to be aware of the wire type that's going to be used on the circuit. I believe THWN 60 copper is the default value. So you have to go in and change each time if it's going to be something else. Anytime we're going to have a breaker at or over 100 amps, we need to use the 75-degree rated cable. That's a section out of NEC. I can't remember the exact one, but just remember 100 amps or greater on your breaker size, then you need to change the wire type to THWN 75. And to do that, if we come back to this panel, we come up to electrical circuits, this wire type right here. We'll change that to 75 and you'll see the wire size gets smaller